Hello, welcome back everyone. So we're going to do here. Hello, this is Naghmana. Let's we're doing the Spec Maths Exam 1 2021. So we're going to do question number 4. Let's see what the question is has for us. So there is a shaded region given for bounded by the graph y is equal to sine x. So our y is sine x and the x-axis between the first two non-negative x-intercepts of the curve, which is given there. The shaded region is rotated above the x-axis, so we need to find the volume of to form a solid of revolution. Find the volume of solid of revolution. So that would be Vs would be 0 to pi times y squared. So that's the formula we have. So this would be pi sine square x dx. So we just need to integrate that. So pi is sine square x. We can't really do directly integration. So what we need to do is need to use the double angle, the formula to convert that into the simple form, which would be 1 minus cos 2x over 2 dx. And then we can differentiate it, anti-differentiate it. So we will get Vs is equal to pi on 2 and x minus sine 2x over 2, and the limit is 0 to pi. And then we apply the limit, so we get pi minus sine 2 pi over 2 minus 0 minus sine 0 over 2. Sine 0 is 0, sine 2 pi is 0. So all of this becomes 0. So we get pi squared over 2. So that's the Vs for us. Okay, I think this is a pretty good question. We got a 3-mark question, and it's pretty straightforward. And now let's look at the next part of the question. So where it says, now consider the function y, which is sine kx, where k is the positive real constant. The region bounded by the graph of function and the x-axis between the two non-negative x-intercepts of the graph, and about the x-axis of the solid of revolution. Find the volume of the solids in terms of Vs. So it's like what is happening is the volume we need to find out, and which, if we notice that what happened to the function is we had y is equal to sine x. Now it's y is equal to sine kx. So the solid is being dilated by a factor 1 over k in the x direction. So what is that mean? So we could say that the volume is going to be 1 over k Vs, right? Because if we pay attention on the question, so we say we already know y is equal to sine x, and we work that out. What is the with the solid of revelation we have now is just being dilated by a factor 1 over k. So so that means the volume should be equal to 1 over k times Vs. So that's what they wanted us to write in terms of Vs. We don't need to write in the answer. It's just that should be enough. Okay, so next, our question number 5 now. Find the gradient of the curve with the equation is this at the point 2, 1. So this is our implicit function. So we need to find out the gradient. Gradient means we need to differentiate that function. So this equation, so we go and do that. So it differentiated with respect to x will give us product rule, Ex is Ex, e to the power 2y plus ex, and then the derivative of that would be 2e to the power 2y, and then we have dy over dx plus e to the power 4y square times by 8y, and then dy over dx is equal to 2e to the power 4, which is a constant. The derivative would be 0 with respect to x. And then we're going to collect the 2 dy over dx together. So this will give me dy over dx is 2e to the power 2y plus 2. I can write it like this, and this would be plus 8y e to the power 4y square is equal to minus e to the power x plus 2y. And then we say dy over dx is equal to minus e to the power x plus 2y divided by 2e to the power 2y plus 2 plus 8y e to the power 4y square. Now, what we wanted, we want to find out the gradient of the equation at gradient of the curve at 0.21. So that means when x is equal to 2, at x is equal to 2 over dy over dx at x is equal to 2 would be when x is 2 and y is 1. So that would be equal to minus e to the power 2 plus 2 is 4 over 2e to the power 2 plus 2 is 4 plus 8 e to the power 4. So that will give me minus e to the power 4 over 10 e to the power 4. E to the power 4 and e to the power 4 cancel out, and we get my negative 1 over 10. So that's nice, simple enough answer for this one. Thank you. Please watch this space for the more videos on spec math solutions. So keep watching. If you like this video, please subscribe to the channel, share with other students so that they can get advantage of that as well.